Welcome to AI Podcasts. I'm Ethan, and today we're unpacking a 2023 EMNLP paper called ClusterLLM. The short version is this. The authors show how to use an API-only large language model to guide a smaller sentence embedder so you can cluster text better and even pick a sensible number of clusters at about 60 cents of API cost per dataset. In tests across 14 datasets, that guidance generally beats strong baselines.
I'm Lena. 60 cents per dataset sounds surprisingly low. And just to confirm, the large language model isn't doing the clustering itself, right?
Right. The LLM never provides embeddings. It answers a small number of targeted questions that steer a conventional pipeline built on an open embedder. The work is by Yuwei Zhang and Jingbo Shang's group at the University of California, San Diego.
Okay, that helps. Who is this approach for in practice? People who already run k-means or agglomerative clustering and want cleaner groups.
Exactly. There's a common pain point. API models like GPT are powerful but don't expose embeddings, while smaller embedders, like E5 or Instructor, are fast and open but may group text by the wrong perspective. Say topic when you care about intent. And choosing how many clusters to keep is tricky. ClusterLLM uses the LLM as a teacher to address both.
When you say perspective, you mean the criterion for grouping, like intent versus topic versus emotion. And granularity is how coarse or fine the clusters are. Is that right?
That's it. The method runs in two stages. First, for perspective, it builds small triplet questions, given an anchor sentence, which of two options is closer under the perspective you care about. Those answers become supervision to fine-tune the small embedder. Second, for granularity, it forms a cluster hierarchy and asks a few yes or no questions like, do these two examples belong to the same category? Then picks the level that aligns best with those answers.
So the LLM is basically a very targeted labeler used sparingly?
Exactly, and the questions are chosen carefully. For the triplets, they focus on cases the current embedder is uncertain about, which makes each answer more informative. For the pairwise questions, they sample across the hierarchy so the LLM sees examples that span the coarse-to-fine range.
What did they actually test this on?
14 datasets across tasks like intent and domain discovery, type and relation discovery, topic mining, and emotion detection. Each dataset comes in small and large versions. They fine-tune strong public embedders, including E5 and Instructor. Most prompts use GPT 3.5 with concise instructions and a modest temperature. The budget was around 1,000 triplet queries for perspective, plus a small number of pairwise questions for granularity. To keep costs down, they ran the overall pipeline once per dataset and evaluated with standard clustering metrics.
And how much did it actually help?
With the number of clusters known, the fine-tuned embeddings consistently improved over their raw counterparts and over a deep clustering baseline. On a representative intent dataset, accuracy moved from roughly 60% to the high 60s after one pass, and a second pass nudged it to around 70. Similar trends showed up across several other tasks.
Nice. And what about choosing how many clusters to use?
The LLM-guided granularity step outperformed common heuristics like silhouette, elbow, x-means, and BIC on a majority of the tested datasets. It was especially good at separating intents from broader domains, where the classical methods often predict similar counts.
I like that it uses the LLM as a compass rather than trying to do everything inside it.
Exactly, and the authors kept the API footprint small, roughly 20 cents worth of queries for perspective, and 40 cents for granularity under their settings with GPT 3.5.
Before I get too excited, what are the main limitations?
3 stand out. First, the method relies on a decent starting embedder to decide which triplets are most informative. If the base embeddings are weak, sampling helps less. Second, although the API cost is tiny, you still need compute to fine-tune the embedder. Earlier attempts to avoid training with constraints were too sensitive to noisy labels. Third, for coarse domain discovery, the gains can be small or even negative. And of course, sending text to an external API raises privacy considerations.
What about reproducibility? Any caveats there?
A practical one. To save costs, the full ClusterLLM pipeline was run once per dataset, so there may be some run-to-run variance. They did repeat the downstream clustering with a few random seeds, but the teacher's answers themselves weren't exhaustively resampled.
If I wanted to try this at work, where should I start?
Begin by writing a clear instruction that matches the perspective you actually want, for example, intent or topic. Fine-tune with a modest number of triplets, then check a few levels of the hierarchy with pairwise questions to choose granularity. If your data is sensitive, consider redaction or an on-prem alternative for the LLM step. And if your goal is broad domain grouping, verify whether fine-tuning really helps on a small pilot first.
Where could this line of work go next?
Two directions look promising. First, replacing or reducing fine-tuning with more robust constraint-based clustering so you keep the gains with less training. Second, smarter sampling policies that mix uncertainty with diversity, plus broader tests across prompts, models, and languages. The authors also point to a public code release if you want to explore further.
That's a solid, practical takeaway. Use the LLM to teach, not to do the heavy lifting, and spend just a handful of queries where they matter most.
Well put. That's it for today on AI Podcast. Thanks for listening.